Hello, welcome to this lecture video. I'm Teacher Melay. So our topic for today's discussion is epidemiology approach and methods. Okay, so we have here a diagram that shows the different types of epidemiology studies. So in an experimental study, so for epidemiology study types, we do actually have experimental and observational. So in an experimental study, the investigators can control certain factors within the study from the beginning. So an example of this type is a vaccine efficacy trial that might be conducted by the National Institutes of Health. In such a trial, the investigators randomly control who received the test vaccine and who does not among a limited group of participants. Then, they observe the outcome to determine if it would or it should to be used more widely. So, in an observational study, on the other hand, the epidemiologist does not control the circumstances. So these studies can be further subdivided into two, which is descriptive and analytic. So for descriptive epidemiology, this is more basic of these categories, and it is fundamental to what epidemiologists do. So in a descriptive study, the epidemiology collects information that characterize and summarize the health event of course, problems. While in an analytic study, so the epidemiologist relies on comparisons between different groups to determine the role of different causative conditions or risk factors. Okay, so time, place, and persons is the mantra of epidemiologists. So another way of comparing descriptive and analytic epidemiology is to say that during the descriptive process, we are concerned on the following, or rather with the following questions. So what are these questions? When was the population affected? Where was the population affected? And who was affected? So for descriptive epidemiology, we are concerned and answering when, where, and who. Okay, so for from the observations gathered during the descriptive process, a hypothesis is generated about the causes of observed patterns and the factors that increase risk for disease or injury. So now, to test this hypothesis, epidemiologists must use analytic epidemiology process in which they asked how and why the population was affected. Okay, so let's have here an example. So let's look this example. So in 1982, an epidemiologist in the Georgia Department of Public Health became interested in the number of deaths associated with farm factors. So he determined he could examine this problem by using readily available data. So death certificate records that were included in an existing surveillance system. So he obtained the death certificate records for all the deaths that had occurred in Georgia from 1971 through 1981. And then, of course, he identified or he described some of the characteristics of the of the involved cases. So they were associated with, of course, the farm tractor incident. So after collecting the data, he used the information to describe the problem in terms of, so as we have mentioned, we have the descriptive, the time, the place, and the person, and then generated hypothesis for further study. And thus, he also applied analytic epidemiology. So we'll talk about, of course, all of this maybe in the next slide, but we have, of course, to consider first descriptive epidemiology. So let us move to the next slide. So we have a table here, or rather a graph, showing fatalities associated with farm tractors. So this graph described the when for 166 of the farm tractors, so there were 166 associated deaths. So we can examine the data by looking at the time of the day when the deaths occurred. So in our x-axis, we have the R incident occurred, while in our y-axis, we can see there the deaths. Okay, so let's also consider the highest or the peak of this graph. So we have a 17 and 25, and this is between 11 to 12, and the other one is between 4 to 5 p.m. And we can also notice here, so we have here from 12 to 1, there is a decrease. So which means we can infer that deaths occur when farmers are probably most fatigued right before lunch, which might lead to the increase in death in late morning. More deaths occurred in the late afternoon when children are home from school. So maybe, or conversely, fewer deaths occurred while the farmers are probably eating their lunch. So that's between 12 to 1. Okay, so let's consider this second figure. So this graph tells the who. So it indicates the number of deaths by the age group. So now, what else can we infer? So in our first figure, we have the R, but in this next figure or this second figure shows that the x-axis now is age group and death. So an increase in the number of death occurs among older persons. So we have 60 to 69 years old. This is the peak, which again is part of the descriptive analysis. So by analyzing this data, which age group is at great risk for death from tractor-related incidents among the population? So we can just see the number of deaths, and that is 60 to 69 years old, but it only shows the frequency and not the rate. So of course, frequency is different from the rate. We just need the frequency for us to compute the rate. That is, if we have the population, because looking at the value of the rate is, obtaining the value of the rate is computing for the frequency of age 60 to 69, for example, all over the population. So of course, unfortunately, we cannot tell because absolutely we do not have the data for population. So we have incomplete or insufficient data for us to determine the to answer that question. So in this table, it just shows us the frequency. But of course, it is not correct to just jump into conclusion that since this is the highest frequency, it already means that this is the answer. So it does not mean that they are already the greatest risk for death from tractor-related incidents because we do not have the data for the population of each group. So, of course, we have some other questions in our mind, like do the higher death number among persons 60 to 69 reflect the fact that the users are predominantly older? So that older tractor users might be more likely to have an unintentional injury or less likely to survive an incident. So we need to understand who is, of course, driving the tractor. So why do you think tractor-related deaths occur among 0 to 9 years old? Are the children playing on tractor and fatally injuring themselves? So these examples illustrates how descriptive epidemiology can be used to characterize specific problems in terms of the when, the where, and the who. And it can help generate a hypothesis for further study to answer how and why the problems or the problem occur. Okay. So let's consider another figure. So this is fatalities associated with farm, still with farm tractor. And this map describes where. So now it's where. It indicates the number of deaths by country in Georgia. So most of the deaths occurred in the northern areas of Georgia, which has the more mountainous terrain, so fewer deaths occur in south, which is characterized by much flatter farmland. So you also need to consider the description of the location. So not just because you just want to see, so what might be the factors associated why there are more incidents in this place than in other place. So can you infer that the distributions indicates that the rugged terrain is responsible for more tractor-related incidents? So remember that the maps indicates the number of deaths, so not the rates again. So the number possibly reflect differences in population or the number of tractor being used. So more farming occurs in South Central Georgia. Therefore, the number of tractor probably does not explain the difference. Perhaps geographic difference exists in the experience or skill level of those using tractors. Okay. Now, let us consider these items before we end with our discussions. So what are these questions? So what we are going to do is to choose the correct answer, whether the item is a qualitative, experimental, or observational. Okay. An epidemiologist is doing a study on a sleep pattern of college students, but does not provide any intervention. So what type of study is this? So do you think this is the qualitative, experimental, or observational? Okay, it is letter C, observational. Okay, let's move. In this item, let us also choose between descriptive or analytic. So a study of heart disease, comparing a group who eats healthy foods and exercises regularly with one who does not, in an effort to test association. So what is this type of situations or scenario? So the reason, of course, why you are comparing a group who eats healthy food and exercise with the one who does not is because you are thinking that exercise or health or lifestyle is a possible factor that influence now an individual with heart disease. So definitely you can do that by using analytic type. Number 2. So our answer for number 1 is analytic. While for number 2, a study to describe the eating habit of adolescents aged 13 to 18 years old in community X. So this is also obvious because what you just need to do is to describe. So simply, this is descriptive statistics. So this ends our discussion for this lesson. Thank you for listening.